Cool. Well, thank you for having me coming to hear this. My name is Fedichev. I represent Gero. This is a company that is this is a biotech company that is working on building biotech solutions for radical life extension. So next slide, please. Well, actually, I'm not a biologist. I'm not a doctor. I was trained as a theoretical physicist, and in 2015. Somebody showed me examples of animals that do not age, actually mammals. I will show you some examples of that. And well, 10 years fast forward, we have a company that is working with the best names in world pharma. We are well published, so I think you can Google us and see what we do. And what I will try to do right now for you is to give you some outlook, what is possible and what is going to be possible within, let's say, 5 to 10 years. In terms of life extension by means of biotechnology solutions. So the next slide. As you know, we are talking right now at the epicenter of demographic catastrophe, which is Asia. As you know, many countries around here are experiencing rapid population aging. So these two charts actually show you the percentage of people over 65 10 years ago and in 20 to 30 years ago after. And you can see that the population ages at a very fast rate. So the next slide. Unfortunately, as you know, with age come diseases, and then on the right chart you see how quickly chances of chronic diseases are going up as we age, meaning that as we are aging as a population, the total disease burden is growing very fast. The next slide. It's growing so fast that suddenly there are drugs that are selling for more than $50 billion. That's actually Ozempic last year. And this is not a coincidence. This is actually a consequence of rapidly aging population. So the more aged people, the more people with diseases, and the more pharma is going to sell. So that's why suddenly pharma is getting a lot interested in age-related diseases and aging in particular. So that's why pharma is now doing lots of deals with biotechnology companies that are working on aging precisely. So Google has done a deal with a company in licensing the research that has been done partly at the US. Sam Altman-backed company, recently Novartis made a deal with BioAge, which is an American longevity biotech. So this is really, I mean, think about this. For pharma companies that have their Ozempics right now, what would be the next multiple $1 billion opportunity? And this is only a drug against aging. So Sam Altman made a prediction a few years ago that the company that would extend lifespan by 1 year would be worth $100 billion on the market. Ozempic is probably extending human life by a year or two, and the company that created it was worth $500 billion. So Sam Altman was actually right. So the next slide. Well, aging is not only diseases, and I think this is like super important to understand because this gives rise to a very interesting fallacy. Many people are very concerned about lifestyles and healthy lifestyles, you know, exercise, diet, and everything else, pretending that if they do everything correctly, they are not getting diseases, and that's why they are not aging. This is not true. These are the two most horrible graphs I think I can show you during the presentation. On the left, you have something that is called VO2 max as a function of age. This is actually the energy generation capacity. That's going down as we age, even if we don't have diseases. So at about 120 years old, people don't have any capacity even to breathe. And then on the right part, I have a chart that is showing you how cognitive tests are going down with age. And as you can see, even without neurodegenerative conditions, what is called fluid intelligence, which is basically your IQ, is also going down linearly with age and hits zero at about 120 years old. That's actually the situation when people who are old can still talk. So this horizontal line there is what is called crystallized intelligence. This is the basic learned skills. And these people can still talk, but they cannot help with math problems already for their kids. So the next slide. So this is functional decline. So you may ask the question, why do I believe that you can do something with that? Because for the last, I don't know, billions of years, people and other animals were aging and dying. So maybe that's a rule of nature. And this is not. So on the right here, I have the chances to die as a function of age for a bunch of animals. And as you can see, in this black curve, this is not log plot, the actual plot, this is the chance to die for humans as a function of age in units of development time. And then if you can see that there is this green line, and this is the probability to die for animals, which are these pretty creatures like naked mole rats. I mean, these guys for a very long time, for like 40 years, do not have any appreciable increase in the probability of death. So technically, these animals are either not aging or aging very slowly. So essentially, nature provides us examples how not to age. And the next slide. Surprisingly, there are many, many animals that are either not aging or aging very slowly. And there are lots of mammals among them. And the most interesting examples are bats. Lots of bats are not aging, and by the way, bats are flying mammals. If you want to fly, believe me, you have to have very high metabolism. And that gives you actually hope that you can achieve not aging without sacrificing metabolism and quality of life. So the next slide. So obviously people understood this situation pretty long time ago. Actually the whole field of longevity biotech, in my opinion, was created by Aubrey de Grey. He is actually a computer scientist who wrote a book about aging for other non-aging people. So essentially he explained to IT people that aging is a bunch of bad things. And since then, venture capital invested in lots of companies, basically 1,000 of companies against any hallmark of aging. And now in 2025, we have like 20 years of this program already. So I think it's a good time to reflect what is expected, what is possible, and what is expected from the whole industry. So the next slide. Next slide. So last year, X Prize was announced, the Longevity X Prize, where people are giving money to test essentially all available longevity interventions in humans. 100 millions will be awarded to a team that will achieve meaningful rejuvenation in a few years from now. So the next slide. Lots of things are going to be tested, so they have a bunch of finalists now. So there are like more than 1,000 teams that are doing lots of interesting stuff. Lifestyle interventions, drugs, AI advisors, everything. I mean, the program covers everything. So the next slide. Every non-aging biology is covered, so really a good selection of teams. And the next slide. Every non-target in longevity molecular target is covered. And the next slide. If you take all those teams and ask AI, ChatGPT, what is the expected effect size for all those interventions in humans, you would find that AI, in its infinite wisdom, believes that most of those interventions will give us just a few years of life, which is quite interesting. So with all this magic and splendor of the longevity biotech, most of the teams are working on incremental solutions. And those incremental solutions are on pair with lifestyle interventions and the best drugs like Ozempic. Next slide. So we didn't believe much in that hallmark of aging program. And the next slide. And since about the inception of our company, we started thinking that you would rather be learning about aging and age-related diseases from human data. We live actually at a very interesting moment in time where more than 500 million people have their medical histories in digitalized form. More than 10 million people have these genes, their genotype. And together, this can be used to train models of health that actually show how aging and diseases progress in humans. So the next slide. We build models that take medical data today and try to predict medical data in 2 years, 4 years, till the end of life. It's not language models. We're trying to predict the future of medical interactions for a particular human with the medical system. And if these models are trained correctly, they understand how diseases affect other diseases, how they interact with each other, and to aging. So the next slide. So what next? Yes, this. So the output of these models actually connects through genetics, molecular biology to diseases, and in this way, nature runs clinical trials for you. So you look how people with different mutations age or having or not having diseases at a different rate, and some of these things can be validated. So we validated some of the biology at NUS with Brian Kennedy and others. And just a few months ago, we landed a deal with a major company that includes quite substantial. So, pharma is super interested in age-related diseases, in applying machine learning to identify targets against age-related diseases, and pharma is already paying. So I think that has a huge potential, and there was just a panel here suggesting that if we collect more data on aging humans, we will identify even more interesting biology. And what I'm saying is that pharma is ready to buy that, because pharma needs aging biology as it has never needed before, because population is aging. Next slide. So the other thing that these models are telling you is this, that there are certain features of aging in humans that are not reversible. So most of human aging is not reversible, meaning that you can do only two things if it comes to regulation of lifespan. You can either try to cure diseases, and some of them are reversible, so that's on the left. So in that way, you can add maybe 10 years of life, because why? Because diabetes takes 6 years of life, early diabetes, so please don't get it. Obviously, that's why good drugs against diabetes help extend human life, but overall effect is not large, it's like 10 years. And then, on the right, there are things that are not reversible, that they can only accumulate as we age, and you can only slow them down. And by slowing them down, you can extend life by a lot. So if we're thinking about radical life extension, this is not related to diseases, this is related to functional decline, and drugs that would intercept functional decline will actually provide a radical life extension. Next slide. So the models are telling you that you can achieve radical life extension or any life extension first in three ways. So first you can cure diseases, as I said, that's a small effect. And this is the bread and butter on modern pharma. That's what pharma is doing. You don't need longevity biotech for that. The next thing is that you can regulate biology that is responsible for the difference between the average and maximum human lifespan. Maximum human lifespan right now in humans is about 120 to 150. Nobody knows where exactly. And the average lifespan here in Singapore is 80 years. Meaning that you can generate drugs that can actually make 80 years to 120 years old, so that would be a radical life extension, with the only caveat is that this kind of technology will not intercept functional decline. So this is almost like a future that nobody wants. Like people are not allowed to die, but at the same time they are functionally declining. So but I mean, even that would be quite an interesting solution. And then there is another level of technology that is closer to replacement, and that technology would be able to change the maximum human lifespan. The most important thing is that most of the people are working on top of this diagram, so people are still curing diseases. Regulators don't like regulators are not subscribing to the idea that aging is a disease. So that's why everyone is working on top, and that's why everyone is generating incremental solutions. Whereas the true solution, I mean, the future that everyone wants, in fact, is the solution where the last line, the level 3 drugs that are changing the human maximum lifespan, are actually produced. This is not a medical problem right now, but this is a technological problem, and we're kind of calling everyone to focus on those, because everything else is a very bleak version of the future. So the next slide. So essentially, we can separate all longevity companies by belief, the horizontal axis, and ambition. So pharma is an industry that believes that aging is not reversible, so that's why they don't even care about aging. And they're not very ambitious, so they're curing diseases, and they believe that they can increase human lifespan by a few years. So that's how pharma works. And then on the left, there are longevity companies. Some of them, I mean, most of them believe that aging is reversible, but most of them are also not very ambitious. Even if you go to Retrobio, for example, the company that is funded by Sam Altman, they only promise you that with all their financial and technological might, they are dreaming to extend human lifespan by 10 years. So this is like the lower left corner. And then, of course, there are big corporations like Altus Lab, who are funded by Jeff Bezos and guys. I mean, the seed funding there is $3 billion, by the way, which is quite interesting. And these guys believe that aging is reversible, and they're trying to do it in a big way. They really want to revert aging by something like 20 years. And then there are companies like us, where we believe that aging is mostly not reversible, but it can be stopped, and by stopping aging, you can extend life by a lot. So the next slide. As Elon Musk is joking that physics is the law and everything else is recommendation, essentially meaning that by market and physics forces, all the companies on the left, because they believe in the wrong thing, they will either die or become standard pharma, right? So I believe that both Altus Lab and Retrobio will develop great drugs against specific diseases. But what most important is that to live long and remain in a good quality of life, you have to actually focus on stopping aging rather than trying to revert it. And that's why I think when this ice cracks and most of these companies will go into the kind of standard biotech operations, there will be very few longevity companies that are still working on radical life extension, and that's why we're kind of calling for more attention to those. So the next slide. Well, I think that's kind of a place for your questions. Maybe to summarize these things is that it's super technologically possible to create drugs that would extend life by a lot more than a drug against diabetes. The only problem is that this will not be a medical technology. It's a biotechnology which will not cure any particular disease, but which will postpone multiple age-related diseases. It's very interesting to talk about it to crypto community, because in my opinion, crypto community is a very interesting demographics. This is the youngest community with resources on the planet. And I think you guys can make a lot of difference here. So a company, New Limit, for example, is funded by a founder of crypto exchange, for example. I think lots of people in the community are interested in aging. We have lots of efforts in decentralized sites. So I think, crypto community has time to make a difference here. So that's why I'm inviting to learn more, to study more about biology of aging. I think this is the most impactful problem that can be solved in 21st century. I'm having Maxim Holland, who is my co-founder here, in the characteristic T-shirt, having a Gero logo. So please talk to me and him, and if you have any questions and if there is any time, I'm happy to answer.
So we'll be able to take one question, that'll be it.
Nice to meet you here. I do have a question. Since you're doing the computational model, right? So
Yes.
how do you say the Web3, the blockchain, that technology can integrate into your agent model?
Well, I mean, the direct answer right now, in no way, but all our models require lots of data, and that has been just discussed before. All this data is now separated in different places. It's very hard to move or even to get access to. Well, I'm in Singapore for more than a year, but I don't have access to Singaporean cohort, for example. Even, yeah, you too, right? I mean, that's the situation. So what I believe that with this zero knowledge proof technologies, with this data federalization, by storing data encrypted and by controlling access to that, somebody will, I'm sure, make a way to use this data for research and for business in a transparent way, in such a way that we can train even bigger models.
Actually, for now, not sure. Need to check the schools policy and government policy. If the researcher can collaborate with the company like that, crypto or the firm that gather data, and then so everyone can control their own data and then decide to use for longevity or not, right?
Yeah, I think this is the end point which we all want to achieve, right? So there is lots of data everywhere in a way that nobody can use. 200,000 people a day die from age-related diseases. So I think this is not ethical.
Okay, thank you so much for your question. Thank you, Peter. Okay, so